Hello guys, welcome back to my YouTube channel. My name is Dr. Sammy, and then we'll continue from where we stopped last class, which is what differentiation from what first principle. So but today we'll be doing another subtopic under differentiation, which the first subtopic is general formula differentiation, and then the second thing I'll be teaching you today is rules of differentiation. I'll teach you one of the rules of differentiation, which is what function of function or chain rule, and then I'm going to what show you what the special derivatives. So now let's start with general formula of differentiation. So I'm taking the general formula of differentiation first. General formula of differentiation. Formula of differentiation. Now in this lesson we'll be solving some Jamb questions, so please take note. Ensure you watch this video or lesson till the end. So now we'll be taking general formula of differentiation first. Now there's a general formula we use in differentiation equation. Now what's the general formula? It is nxn minus 1. This is the general formula we use in what? Differentiating any equation. What does this mean? If you want to apply the general formula to differentiate equation, let's say the equation is y equals to 3x squared. Now what it means is that your power is the n. Are we together? The power is the n. So in using general formula to differentiate, we take note of the power. So we use the power the most, the y, the x. So following this general formula to differentiate this equation, it means that the n will first multiply what? The whole equation. So if to multiply everything here to become, which is the n multiplying the equation, it becomes 2 times 3x squared. So that's the first step. This n will multiply the whole equation, become 2 times 3x squared. Then take away 1 from the what? Power minus 1. So if you have done this, you have differentiated from the first principle. 2 times 3 is what? 6x. 2 minus 1, is it not what? Is it not 1? So therefore, x is power 1 is still what? X, so our answer is 6x. So differentiating with general formula, our answer is what? 6x. It's still same thing with what? If you use differentiating from the first principle to apply it to differentiate this equation, it will still give you same answer with what? General formula. So the general formula is just one of the easy way to what? Differentiate. Just a shortcut. Now let's me show you another one. Let's say you have y equals to 4x cubed. How do you differentiate? You use the word power to multiply the whole equation, become, that is the y the x become 4 times 3x, take away 1 from power minus 1, so therefore it becomes 4 times 3 is now what? 12, x, take away 1 from power becomes squared. So we have differentiated this equation. As simple as that. Now, before I proceed, let us differentiate ordinary x. Now the power of ordinary x is what? 1. So therefore it becomes the y dx equals to, just the power of ordinary x is 1. So 1 will multiply the equation to become 1 times x. Since the power of what? Ordinary x is 1. So now that 1, so that's 1 from it. So it becomes what? 1 times x. Now 1 minus 1 is 0. Now in mathematics, if you put your calculator, any number or any alphabet raised to 0 is 1. So it becomes 1 times 1, so equals to 1. So take note, when you are differentiating ordinary words, variable, when you are differentiating ordinary letter, your answer should be what? It's constant. Your answer is what? 1. And then in differentiation, when you differentiate ordinary number, your answer is what? 0. So NB, when you differentiate only a letter, then your answer is what? 1. When you differentiate only number, then your answer is what? 0. Please take note of this. Very important. Very important. Now let me apply this. Let's say we have y equals to 3x squared plus x plus 1. So differentiating this with general formula becomes, I said you use the power to multiply the equation, it becomes 2 times what? 2 times 3 is 6x. Remove 1 from it, it becomes what? 2 minus 1, it becomes 6x. So if you differentiate this, we are differentiating this before. 6x plus. Differentiating ordinary alphabet, I told you is 1. Differentiating number is 0, so it's nothing. So therefore, my answer is what? 6x plus 1. Take note of that. So now, we move to the what? Other part of differentiation. Now, rules of what? Differentiation. One of the rules of differentiation is function of function or chain rule. But now, before I will show you how to use function of function or chain rule and where it is applicable, the first thing I will show you is special derivative we have. So now I'm going to show you the special derivatives we have. Now, special derivatives are those functions that are not, that you cannot differentiate. They have constants. So their differentiation is constant. Like for instance, if you differentiate in x or log x, it is what? 1 over x. So and then let's say differentiate e raised by x, it's what? Ex. Let's say differentiate sin x, it is what? Cos x. So take note of this. If you differentiate cos x, it will become what? Negative sin x. So please take note of this. If you differentiate cos x, it will become what? Negative sin x. If you differentiate cos x, it will become negative sin x. And then if you differentiate tan x, it becomes x square x. If you differentiate cot x, become minus cos x squared. Now if you differentiate sec x, it becomes sec x tan x. And if you differentiate cosec x, it becomes minus cosec, becomes minus cosec x cos x. So please take note of this quote. The constant derivation of these functions. So take note of them. We will be using it. So now please take note of this. The constant function of derivation. Now, which are what we call special derivatives. So if you differentiate any of these constants, you surely get this. No matter what it is, the derivation is always constant. So now, the next part of this lesson is function of function or chain rule. So now, function of function or chain rule, this is the formula. The y dx equals to du dx times the y du. So that's the formula. The y dx equals to du dx times the y du. Now, how do we apply this formula? It is very what? It is very easy. Now, how do I apply this formula? I've said that it is what? Very what? Easy. So what should come to your mind is that how to apply this formula. So this function of function or chain rule, we apply it to equations that are in brackets that have what? A higher power of what? A higher power degree. Like for instance, 1 plus x raised to what? 20. We use what? Function of function or chain rule to differentiate. So we use it to differentiate equation that are in bracket that is raised to what? A higher degree of power. And then we use it to differentiate equations that is having roots. So we use function of function to differentiate equation that is having roots or higher power in brackets. So now, let me differentiate using function or function or chain rule. Now, I have some what? Jamb questions here. So the first jamb questions I have here is what? Let's say y equals to what? 1 minus 2x raised to power 3 is 2005 question 1 UTME question. So now I'm going to use those function or chain rule to differentiate this. So it will become, now to use function of function chain rule, you represent the equation that is in the bracket with what? U. So U become y minus 2x. So now once you represent the equation in the bracket with a letter which is U, you differentiate the what? The letter to become the U what? The x. You differentiate the equation in the bracket. That's if you differentiate 1 is what? Is 0. And if you differentiate ordinary letter, it is what? Ordinary letter that does not have power, it is what? It's 1. So differentiation of this becomes what? Minus 2. Now let me show you. This is 0 and this is minus 2x raised to power 1. So if you multiply that, all the equation with power, it will become times 1. Take away 1 from this, so it will become minus 2x. 1 times minus 2 is still minus 2x. 1 minus 1 is 0. I told you x raised to power 0 is what? Still 1. So it becomes minus 2 times 1. And your answer is minus 2. So same here. So if you differentiate ordinary letter, it is what? 1. So minus 2 times 1 is minus 2. And if you differentiate ordinary number is 0. So that's why the differentiation is minus 2. Now what's next? Y equals to, now you know everything in the bracket is your U. So it becomes U what? Q. So now we have gotten here the U dx. Become U Q. So now we differentiate together and divide the U. So multiply 3 with the U. I've told you 3U squared. Using what? General formula of differentiation. So now remember that the y dx for function of function is what? Just what? The U dx times the y du. That is just it. So that's the formula. So how do we apply it? It becomes the y dx for that Jamb questions. We are solving du dx is now what? Du dx is minus 2 times the y du is now 3u squared. So therefore our final answer will be minus 2 times 3 is what? Minus 6u squared. Now what do we represent as our u? Now remember that the equation we are solving for is 1 minus 2x cubed. So our u is what? 1 minus 2x. So anywhere we see u, we'll put what? 1 minus 2x. So therefore my answer will become minus 6, 1 minus 2x squared. So this is my final answer for this question, differentiating this question. So now let me proceed in solving more examples so that you finally grab this this thing I'm saying. Let's say you have to differentiate y equals to 1 plus x in square. This is what? 2002 UME question. So now it's very easy. You represent everything in the bracket with what? With u. So it becomes 1 plus what? X. Differentiate the u, it becomes the u dx. So this, if you differentiate ordinary 1 is 0, differentiate x, ordinary letter is 1, I told you that. Then therefore, you write your whole equation, y equals to in terms of u. And you know this 1 plus x is u, so it becomes y equals to u squared. So differentiate y equals to u squared because the y du equals to what? 2 times u, 2u. Take away 1 from 2, it becomes 1. So which is still 2u. Now since you have done this, you know to differentiate with function of chain rule, it means the y dx equals to what? The y du times the u dx. So now what does this mean? It simply means, let me just solve it here so that it simply means therefore my dy dx become, now what is the u dx? 1 times what is now dy du? 2u. So therefore it becomes dy dx equals to what? 2u. Now what is this my u? Our u is what? 1 plus x. So we'll replace our u with its original value 1 plus x. And now this is the derivation of the question. So simple. It is very easy. Very easy. Now let me differentiate another question. Y equals to x squared minus 1 over x. Now this one is not in bracket. It's not having what? It's not having square root. So I will not use what? Function of function. I will use my general rule to differentiate this. So now you have a question. You have to differentiate 2002 question 19. So we have to find the dy dx. How do I go about it? It becomes dy dx Now, before I write the y dx, let me write this equation in simple form minus 1 over x under indices. If you have 1 over a in indices, you can write it as a minus 1. And we can write a minus 1 as 1 over a. So therefore, in indices 1 over x, I can write it as x raised by minus 1. So therefore, I've simplified this to linear equation. Now what can I do? Let me differentiate now the y dx using the general formula. 2 times x become 2x. Take away 1 from the power, it becomes 2 minus 1, which is 3 to 1. So I don't need to write 1. Minus. Now use this minus to multiply the equation, it becomes minus 1 times x raised by minus 1. Take away my 1 from it, the power, it becomes this. So my formula becomes the y dx 2x minus times minus plus. Now it becomes 1 times x is 2x minus 1 minus 1 is minus 2. So therefore my final derivation or derivative for this is now x raised by minus. Now recall that so since we have simplified up to this extent, so therefore our final answer is now the y dx equals to 2x plus now x minus 2 because under indices a raised by minus 1 we can write it as 1 over a. So therefore x raised by minus 2 we can write it as 1 over all the equation without putting the power of minus. So it becomes x squared. So that's just it. So recall we can write this as 1 over everything here without applying putting this on minus. So it becomes 1 over x squared. So and this is our final differentiation. So let me solve another Jamb question under function of functions so that you tell what I'm seeing clearly. So now one more to go. We have y equals to what? Cos 3x squared minus 2x. Now this is UTME 1997. So now this is very simple. We'll use also function of function rule. Why are we using function of function rule? I told you that function of function rule is applied to something that is what in bracket and is what raised to what power, or something that is in what square root. Now function of function is also applied when an integral sign like cos or a function like cos is what is brought together with an equation in bracket. You use what function of function rule. So therefore what do I do here? Then we replace this equation with what? With u. So remember the equation in bracket, we always replace this with what? U. So it becomes 3x squared minus 2x. And our next step is to differentiate the equation in bracket, which is now du dx. So differentiating 3x squared, recall it is 6x. Minus differentiating 2x, recall it is what? 2. So it becomes what? 6x minus 2. Now we rewrite the whole equation. That's the next step. It becomes cos. Instead of writing cos everything here, you remember that we have replaced this equation with what? U. So it becomes cos u. Now differentiate cos u. Recall, I gave you functions and they are what? Constant what? Integration, which we call special derivative. So if you differentiate cos, it will become what? Minus sine u. Now we have gotten the y, sorry, this is the y du. We have gotten the y du and u dx. Now what do we apply? We apply function of function rule, which is what? Function of function rule, let me keep it here, which is the y dx equals to the u dx times the y du. Now very simple. Now the u dx is what? The u dx is 6x minus 2. 6x minus 2. Now the y du is now what? Minus sine u. So this becomes 6x minus 2 open bracket minus sine. Now what is our u? Our u is what? 3x squared minus 2x in bracket. Now we can write everything in this manner. This minus, we can bring it out. Now we should write it this way first. Now becomes 6x minus 2 minus sine 3x squared minus 2x. So we can then write it this way and become, then bring the minus out totally 6x minus 2 sine 3x squared minus 2x, and this is our final answer. So our final, we can either stop here or here. So anyhow the objective answer is, that's where you want to stop. So our final answer can either be 6x minus 2 minus sine open bracket 3x squared minus 2x close bracket, or minus open bracket 6x minus 2 close bracket sine open bracket 3x squared minus 2x. Thank you.